There are code bases, and then there is the Linux kernel. 30 million lines of C and Rust, 35 years of commits. Powers everything from your Android phone to the servers running the internet. It is the most battle-tested piece of software in human history. In 2026, it became the ultimate stress test for AI coding models. The results were not what the AI bros promised. For most of 2025, the AI coding narrative was built on benchmarks, software engineering bench scores, human evaluation numbers, models solving isolated programming puzzles and getting graded on correctness. Those benchmarks kept climbing. The headlines kept coming until the Linux kernel community tried to actually use AI on a real production codebase. Linus Torvalds entered the chat on AI code contributions, and he was completely direct. He called AI-generated submissions pure slop and told kernel developers to stop wasting time debating rules, because in the end, bad developers won't follow them anyway. For Linus, the existing review process was already there for a reason. Sure, AI tools are getting better, but he views them as glorified autocomplete. It is great for writing boring boilerplate code, but dangerous the second you touch deep systems programming like concurrency, memory management, or hardware interaction. The benchmarks AI models ace are greenfield tasks, isolated functions, clean inputs, known outputs. The Linux kernel is the opposite. It is 35 years of architectural decisions baked into implicit conventions that no documentation fully explains. Enterprise AI has a major reality check because there is a 37% gap between lab benchmarks and real-world performance. In the Linux kernel, that gap is catastrophic. A bug in a web app breaks a feature, but a bug in the kernel breaks everything. After months of debate, the Linux kernel project finally established a strict AI policy based on one rule: accountability stays human. AI agents cannot use the legally binding signed off by tag, and a new assisted by tag is required instead. What Linux actually exposed is not a limit of AI, but rather a limit of the narrative around it. The models are impressive on clean, controlled tasks. Yet production systems with history, complexity, and real stakes require something models do not have yet, which is judgment built from years of understanding why things are built the way they are. At the end of the day, code is easy to generate, but great engineering requires judgment. That is why the human element isn't going anywhere. The future still needs people who know how things work under the hood.